The Industrial Revolution forever changed the way people in Europe and the United States lived and worked. There are many, many inventors and creations that were at the forefront of a new society, and it would be impossible to create a video that has all of the inventions that were created during that time. So what we've done is selected the top 5 inventions that drove the Industrial Revolution. And in this video, we're going to look at spinning and weaving, the steam engine, how electricity was harnessed, the telegraph and the telephone, and the creation of the car. Spinning and weaving. The creation of the following ingenious machines made possible the mass production of high-quality cotton and woolen thread and yarn, helping to transform Great Britain into the world's leading manufacturer of textiles in the second half of the 18th century. The spinning jenny. In 1764, James Hargreaves created a new kind of spinning machine that would draw thread from 8 spindles simultaneously instead of using just one, as in the traditional spinning wheel, making the production of products faster and more efficient. The water frame was also known as the water wheel because it was powered by water. And Richard Arkwright patented this in 1769, and it was the first fully automatic and continuously operating spinning machine. It produced stronger and greater quantities of thread than the spinning jenny did. Because of its size and power source, the water frame could not be housed in the homes of spinners like the spinning jenny. Instead, it required a location in a large building near a fast-running stream. Arkwright and his partners built several such factories in mountainous areas of Britain. Spinners, including child labourers, thereafter worked in ever larger factories rather than in their homes. The spinning mule was created in 1779 by Samuel Crompton. He designed it by synthesizing the features of the spinning jenny and the water frame. His machine made it possible for a single operator to work more than 1,000 spindles at the same time. Unfortunately, Crompton, being poor, lacked the money to patent his idea. He was cheated out of his invention by a group of manufacturers who paid him much less than they had promised for the design. The spinning mule was eventually used in hundreds of factories throughout the British textile industry. The steam engine. Through its application in manufacturing and as a power source in ships and railway locomotives, the steam engine increased the productive capacity of factories and led to the great expansion of national and international transportation networks in the 19th century. Watt's steam engine was developed in 1765 by the Scottish inventor James Watt. He built on earlier improvements and increased the efficiency of steam pumping so much so that by the 1780s, Watt's engine became a primary power source in paper mills, flour mills, cotton mills, iron mills, distilleries, canals, and waterworks, making Watt a wealthy man. The steam locomotive was developed by Richard Trevithick, and he's recognized as the inventor of the steam railway locomotive in 1803, an application of the steam engine that Watt himself had once dismissed as impractical. The first steam-powered locomotive to carry passengers was the Active, later renamed the Locomotion, and it was designed by English engineer George Stephenson, which made its maiden run in 1825. For a new passenger railroad line between Liverpool and Manchester was completed in 1830. Stephenson and his son designed the Rocket, which achieved a speed of 36 miles or 58 kilometers per hour. Harnessing electricity. In the early 19th century, scientists in Europe and the United States explored the relationship between electricity and magnetism, and their research soon led to practical applications of electromagnetic phenomena. Electric generators and electric motors. In the 1820s and 30s, British scientist Michael Faraday demonstrated experimentally that passing an electric current through a coil of wire between 2 poles of a magnet would cause the coil to turn, while turning a coil of wire between 2 poles of a magnet would generate an electric current in the coil, known as electromagnetic induction. The first phenomenon eventually became the basis for the electric motor, which converts electrical energy into mechanical energy, while the second eventually became the basis of the electric generator, or dynamo, which converts mechanical energy into electrical energy. Although both motors and generators underwent substantial improvements in the mid-19th century, Their practical employment on a large scale depended on the later invention of other machines, namely electrically powered trains and electric lighting. The incandescent lamp. In 1878-79, Joseph Wilson Swan in England and later Thomas Edison in the United States independently invented a practical electric incandescent lamp, which produces continuous light by heating a filament with an electric current in the vacuum, or near vacuum. Both inventors applied for patents, and their legal wrangling ended only after they agreed to form a joint company in 1883. Edison has since been given most of the credit for the invention because he also devised the power lines and other equipment necessary for a practical lighting system. During the next 50 years, electric incandescent lamps gradually replaced gas and kerosene lamps as the major form of artificial light in towns and cities, though gaslit street lamps persisted in Britain until the mid-20th century. Two inventions of the 19th century, the electric telegraph and the electric telephone, made reliable, instantaneous communication over great distances possible for the very first time. Their effects on commerce, diplomacy, military operations, journalism, and many other aspects of everyday life were nearly immediate and proved to be long-lasting. The telegraph. The first practical electrical telegraph systems were created at the same time in Britain and the United States, in 1837. In the device developed by British inventors William Fothergill Cooke and Charles Wheatstone, needles on a mounting plate at a receiver pointed to specific letters or numbers when electric current passed through the attached wires. American artist and inventor Samuel F.B. Morse created his own electric telegraph, and more famously a universal code, since known as Morse code, that could be used in any system of telegraphy. The code consisted of a set of symbolic dots, dashes, and spaces, and it was soon adopted throughout the world. Telegraph cables were first laid across the English Channel in 1851 and across the Atlantic Ocean in 1858. In the United States, the spread of telegraphic communication through the growth of private telegraph companies such as Western Union aided the development and maintenance of law and order in the Western Territories and the control of traffic on the railroads. What's more, it enabled the transmission of national and international news through wire services such as the Associated Press. In 1896, Italian physicist and inventor Marconi perfected a system of wireless telegraphy called radiotelegraphy that had an important military applications in the 20th century. The telephone. In 1876, Scottish-born American scientist Alexander Graham Bell successfully demonstrated the telephone, which transmitted sound, including that of the human voice, by means of an electric current. Bell's device consisted of two sets of metallic reeds and electromagnetic coils. Sound waves produced near one membrane caused it to vibrate at certain frequencies, which induced corresponding currents in the electromagnetic coil connected to it. And those currents then flowed to the other coil, which in turn caused the other membrane to vibrate at the same frequencies, reproducing the original sound waves. Initially, the telephone was a curiosity or a toy for the rich, but by the mid-20th century, it had become a common household instrument, billions of which were used throughout the world. The automobile. Amongst the most consequential inventions of the late Industrial Revolution were the internal combustion engine, and along with it, the gasoline-powered automobile, or car. The car, which replaced the horse and carriage in Europe and the United States, offered greater freedom of travel for ordinary people, facilitated commercial links between urban and rural areas, influenced urban planning and the growth of large cities, and contributed to severe air pollution problems in urban areas. Because of the efficiency of the car and it being lightweight, the gasoline-powered engine was ideal for light vehicular locomotion. The first motorcycle and motor car powered by an internal combustion engine were constructed by Daimler and Carl Benz, respectively in 1885. By the 1890s, a burgeoning industry in continental Europe and the United States was producing increasingly sophisticated cars for mostly wealthy customers. Less than 20 years later, American industrialist Henry Ford perfected the assembly line methods of manufacturing to produce millions of cars, like the Model T. The great economies of scale he achieved made car ownership affordable for Americans of an average income, a major development in the history of transportation.